What we term the factory of the future, I think it's the same terminology or concept as a smart manufacturing environment. What do we mean by that in my research group, which is, as I said, entitled the Intelligent Efficiency Research Group? We're talking about basically a process that's optimized based on the use of real-time data to identify faults or deviations in performance, using that data to make informed decisions to correct where these deviations occur and improve processes, streamline them, optimize them. So I'm just going to step through this simplistic diagram. So if Jim's diagram was detailed, this one definitely isn't. It's quite vague, actually. So I'll just step through the different processes and explain maybe some of the things we come across in this process. So the first one, I guess, is the data extraction. So all the talk these days is about big data analytics, getting that data into the cloud. But our experience has been easier said than done. You tend to come across problems with that. So those problems can range from, I guess, first and foremost, security issues, whereby sites are very sensitive to their data going on the cloud. Now, our experience has been that is generally overcomable through correct dialogue with in-house IT people and giving them the necessary reassurances around the security of the data. If you're putting their data on, say, an Amazon cloud server, giving them the necessary certs around the security of that. A bigger problem that we found, and again, Jim referred to it, is the communication protocols, I guess, the different vendors and the proprietary communication protocols. So typically, trying to get these systems to talk to each other, and I guess Enrique will talk to this a bit more, but typically you're talking about lots of translators to try and get these systems to talk to each other, and it tends to be a bit of a mesh of it's hard to decipher a lot of the time, and a lot of customized data extraction processes that are not necessarily reusable when you go to the next site. So again, there are people in this space that focus on it, such as the OPC Foundation, trying to improve the ability to extract data in a uniformed fashion. Once you extract that data, again, it needs to be data mined and made sense of, so pre-processing that data. And this is something I think is often maybe overlooked again with all the, I don't want to say hype about data analytics, but for me, we've come across this process on the left of the diagram here, known as CRISP-DM, which is the cross-industry, let me get this right, cross-industry standard process for data mining. And in that, the first three here, I guess, are business understanding, data understanding, and data preparation. And for me, you need engineers that understand processes to really decipher the data. So getting the data out, as we've said, is already a task. But once you get it out, you need to be able to make sense of that data. And that takes, for me, guys on the floor, understanding the process, being able to link data across different systems. So if we go to the next slide, you'll see you might be bringing data from a value stream map. You might be bringing data from some operational system, from an energy data monitoring system. And how do you link all this data? Is it by batch number, by timestamp? There are various ways. But again, it really takes, for me, an engineer to figure out how to link that data up. And all the talk, and there was a lot of talk yesterday about data scientists and behavioral analysts and all this type of stuff. But for me, you still need the engineer to figure out how you link the data together. Moving on with this diagram, the next step is the data analytics step. So we characterize this under the terms here. So descriptive analytics is the very basic stuff. You're using X amount of energy within your factory process. Very, simple dashboard stuff without much, information associated with that. You move on to diagnostic analytics, then you're actually linking it to a cause. So your energy is high because a process ran for 2 hours more than usual. So you're bringing in an element of diagnostics. Moving forward, you go to predictive analytics, so your statistical models are getting a little more advanced, and you're able to it might necessarily be advanced, it could be simple regression analysis, but you're able to say now the weather tomorrow is likely to be X degree days, your heating is likely to be Y kilowatt hours, so that kind of predictive analytics. And then the more interesting one for me is this concept of prescriptive analytics, which is where you're taking these models and you're moving to the next step, and you're basically saying, okay, if I want to produce products, X amount of widgets tomorrow, what is the optimum amount of energy I could use to achieve that goal. So it sets a target for you, an optimized process, if you like. So that we call that prescriptive analytics. Again, what are we trying to do with data analytics? Simply understand operations, improve performance, reduce downtime, increase the output, maximize integration efficiencies. Moving on, the next thing is the decision support. So in decision support, I guess it could be, and Jim referred to this, it could be, automated processes such as, identifying the optimal energy mix on the generation side, and that could be sent to, automated processes without any, human intervention, as it were. Or it could be just simply getting the data to the guys on the floor, giving them real-time KPIs about performance and helping them to flag anomalies in that performance. So again, that speaks to this process of data visualization and mobile platforms and real-time data and all that good stuff, which again we've heard a lot about in the conference over the last day and a half. Excuse me. The last step is process optimization. So, what do we mean by process optimization? Again, it's this kind of vision of a factory of the future with data, coming from both the supply side and the demand side, and mixing it all together into a kind of a cauldron of informed decision making that improves process. Ultimately, that's what we're trying to get to. So that's my quick overview of this vision, if you like, for the factory of the future. What I want to do now is just talk about. So I mentioned